both in radiology and pathology, were 4 things. The first one is I should be able to circle an area within an image, and then go across modalities and say, where have I seen this before? So that's the first requirement. The second one was prior comparisons. Is this image an improvement from my last visit or not? The third issue, the third and fourth issues were workflow, and you're quite aware. Dr. Balis is also on the scientific board of a very interesting digital pathology company. That we spend a lot of, this is the 80-20 rule, we spend a lot of time on the same things. Can we actually get them better? What are the workflows that are involved? Things like DNA, vendor neutral archives, and registries. So if you can just quickly answer that as a, 2 or 3 minute presentation, that would be great for me in terms of information. Thank you.
Or you can sit there and stand, either way it's fine.
I'd like to thank Sanjay and the organizers for the opportunity to share a few observations about pathology with you. Just by way of background, pathology is really at a crossroads of technologies and capability. If you think about the specialty itself, there are about 19,000 pathologists in the U.S., 12,000, for example, who actively practice surgical pathology, so diagnosing biopsies. And of those, the number of pathologists who are formally trained in numeric or quantitative statistical sciences for doing machine learning, deep learning, how many do you think would be that number right now currently? A bunch less than 5%.
Oh, okay.
Actually, much less than 1%. So if I say pathology and pathologist, what comes to mind? And perhaps I'm dating myself, but you think of maybe CSI or Quincy, right? But both of those have the interesting property of dealing with the non-living. Yet pathology is very much a practice of dealing with the living and helping those that have active illness, people who are alive and hopefully will continue to be alive. And yet we have really a practice model now, which is the same as it was in the days of Virchow hundreds of years ago, where we have slides, which are little glass constructs with tissue, human tissue placed upon them, and we look through the microscope. So this is really a guild. It's an art form. It's taught as largely by apprenticeship, and it's an artful skill set, which takes many years to acquire. And it has some interesting properties, which are both attractive but also unattractive. So first and foremost, and I'll use a sort of an analogy to what a pathologist does to things that you might encounter in your daily life. How many of you would be confident in identifying a maple leaf? Right? You all can do that. What if I gave you 10 species of trees, none of them maple leaves? How many of you are confident that you could tell me, just by the outline of the leaf, what species those leaves were? You couldn't do it. Well, maybe a couple of you. So let's say, hypothetically, we had 10,000 species of trees and subspecies. And you had to reliably make the identification, and the analogies, of course, when we look now to morphologies of disease state, tumors, for example, other disease processes in the body, the many organs, that the appropriate treatment, in some instances, hinges on identifying the analogy, that complete and correct leaf outline. Kind of daunting. And so there's several challenges that pathologists face. One is, of course, simple pattern recognition, getting the right tumor or diagnosis based on the pattern, but there's a kind of a secret, nasty underbelly to the specialty itself, which is inconsistency of practice. And so, for example, when I was at my time at Harvard MGH, I started a study, which, as you'll find out in a minute, was not too popular and ended up not being published. It probably should be still, because of the trends. And of course, this is a small n, but I looked at some simple data, which is just which cases resulted in litigation because the diagnosis was not quite right or was completely wrong. And it really the underlying factors were surprising. It wasn't the expertise or a number of years of experience of the pathologist as much as it was a variable that I almost didn't include, which was the time of day. So cases signed out or diagnosed, if you would, in the late afternoon had a much higher rate of misdiagnosis. And if this makes, in retrospect, perfect sense, because this needs a larger n to validate, probably people were dozing off or zoning out from being exhausted from the day at large, and maybe from having a lunch occasion that was a little bit too large. So just missing probably the lesion of interest. And so this gets to the first opportunity and topic that Sanjay pointed out. Get this out of here, no worries. Which is identifying like regions, and then of course if you have a library of like images, they can be tagged with metadata, one of which being the diagnosis, and the term of field is content-based image retrieval, which turns out to be a relatively non-trivial machine vision task itself, and certainly even more non-trivial in pathology. That is the ability to circle a region of interest and say this is the payload region that is likely the diagnosis. Now ask two questions of it. What is the diagnosis as defined by previous images that were matched, and what is the biologic potential? And you have all the variables in the electronic health record available to you from which to interrogate. So not just matching images, but matching images with prior diagnoses and with the outcomes of those patients that were previously matched, for which we already know what therapeutic regimen they were treated with, how long did they survive, was their survival enhanced by that regimen, what is their molecular, proteomic, genomic, so all the omics trajectory, and then if they did not respond, what was the secondary salvage therapy that they perhaps received in the case of cancer, and how did they respond to that? And these are tools that are intuitively obvious for us to have as pathologists, but again, harking back to what I mentioned earlier, that pathologists are fundamentally non-quantitative morphology diagnosticians. You could say visual scientists, if you would. Up to this point, we have not had as a specialty the tools to do that simple type of image-to-image comparison, to say, I have an image, give me all the images in the library that are like this, and what is the biologic potential of this? And so even if you made that technology available, and in point of fact it is available, we have this recent commoditization of scanning of slides, it's called whole slide imaging, which Sanjay, of course, mentioned. We worked on this technology, the precursors of it, decades ago, and now it's come to fruition. But the problem is, as I mentioned earlier, pathologists aren't ready to effectively use this technology. At least most pathologists are. So the crossroads we face is we have an embarrassment of riches in the form of now digitization of the entire specialty, and yet without that technology having expertise, we have challenges of how to most effectively use it. So the good news is there are now algorithms that exist that allow for systematic and largely fully automated interrogation, and I'll mention that in a little bit, how that can help diagnosis. Sanjay also mentioned priors. In other words, now that you've matched the image, you can match then cohorts of matching images. How did those patients do compared to your current patient? What were their molecular features? In tandem with the morphologic features, did they respond immediately to a particular, for example, monoclonal therapy or targeted agent therapy? Yes or no? Again, very easy questions to ask, very difficult to answer. The reality is, however, that computational tools are now making this available, and the opportunity from the perspective of business development is to put those tools into the hands of pathologists. And finally, towards his comment about digital pathology workflow, human factors engineering, user experience engineering is paramount. Because if the tool works but is difficult, cumbersome to use, or difficult to train, I can tell you pathologists won't use it. The average attention span of a pathologist is about 3 seconds for IT. Anything that takes longer, they'll simply go back to their microscopes. So the final story, which I think is a great example of the partnership between academics and industry, I had and continue to run a pretty sophisticated IT shop as part of our research lab at the University of Michigan. Not uncommonly, such shops are rated for their most talented individuals. We lost several people that ended up forming a startup. But the startup, in this case, that was created by the diaspora from my lab, created a very effective image viewer, which can be used on the web as opposed to thick client applications, which are cumbersome. Actually, the CEO of the company, David Bloom, is in the audience here. He was recognized by your group as one of the finalists, so I'm delighted to see that. I have no financial relationship to that group, but the story is that with democratizing tools like that, we can take the algorithms that we've built, which were relatively difficult to share and implement in multiple sites, and democratize them on the web, and in fact in the cloud. So with the help of groups like that, we've taken an algorithm that was just used in our operation, and have made it available on the web, in the Google Cloud, taking what used to be a 160-hour operation and making it real time with GPU support. So as you move around an image, high performance analytics and image matching can take place in real time. And I'm happy to show this, actually works with the cell phone at the end of the, for anybody interested. So the good news is digital pathology exists, and the challenge is now how do we most effectively make use of the petascale data that comes out of pathology practices. Right now, we're just looking at the images, but we know from analytics, deep learning techniques that have already been applied, we can extract incredibly precise biologic potential of survival data or response to therapy. From the image data alone, when we combine that with the omics data, we have extreme precision. So pathology is about to enter the realm of a truly quantitative science, and what is needed, of course, is partners in industry to take the raw data and convert it to actionable wisdom from just being raw information. So thank you.
Actually, we had embarrassment of riches. We had 5 speakers.